Total internal reflection, problem number 3. We have a mystery fluid. A mystery fluid here. Mystery. In other words, n is equal to what? What's the index of refraction? Given the conditions being, focus that thing, that we have an incident ray at the interface here, and this distance is 8 centimeters. This distance is 7 centimeters. This is basically shining a light from this point here. All right. And the question is, this is the situation where it totally internally reflects. So we end up with the TIR situation there. In other words, that reflection is at the same time that the refraction, let me do a normal here, should do that, incident angle, that the refraction goes all the way to 90 degrees. So that's the critical angle. So this is theta critical as well. And to analyze TIR, we go n incident sine of theta incident is equal to n refracted sine of theta refracted. However, as applied to the critical angle, we have incident sine of theta critical is equal to n refracted times sine of 90 degrees. All right, so that enables us to solve for the critical angle, namely that the sine of the critical angle is equal to, I mean, this whole thing is 1, just nr over ni. Now, n is equal to 1 outside of this mystery fluid because it's going into the air, and so this is equal to 1 over n of the mystery fluid. So I'll just keep it incident angle here, or incident index. Okay, so then what we need is something about the critical angle. Well, that's this, and the geometry gives us that the tangent of theta critical, tangent of this angle here, is opposite. The opposite side is really the 7 centimeters. So it's 7 over adjacent 8, which is equal to something, where so that the critical angle is inverse tangent of 7/8, and that's equal to 41.2 degrees. So there is your critical angle, and then we can say that, well, we can figure out what the sine of 41.2 degrees is approximately 0.66. So this is equal to 0.66, or n incident is equal to 1 over 0.66, which is equal to 1 divided by 0.66 equals 1.5, approximately 1.5. Now that basically tells us that if this ray totally internally reflects, then at this point, now it could have conceivably been at less of an angle, So the index of refraction has to be at least 1.5, or basically n is greater than or equal to 1.5 for the mystery fluid. If it was greater than 1.5, certainly at this angle it would experience TIR, but it has to be at least 1.5. So there's problem number 3, and a little help perhaps on how to deal with the critical angle.